So I'm here at the Catania Astrophysical Observatory with Marco Montalto, who is a staff scientist. We've been talking about the PLATO mission, the European Space Agency mission that's going to be launching in 2026. And it's going to do astroseismology, but I've been talking with Marco about its ability to hopefully, once and for all, find another true Earth-like planet. And we hear time and again in the media, every day there's a new press release, every day there's a new article. Flash, we found another Earth-like planet. And that's really not the case, is it, Marco? I mean, a lot of this is hyped up news. I mean, not to come down too hard on my fellow journalists, but we really haven't found a true Earth analog. And how will PLATO help us find an Earth analog?
PLATO will observe thousands of solar-type stars bright enough to be able to follow up them and determine not only the presence of an Earth-like planet in the habitable zone, but also determine the mass of these planets, and therefore truly confirming that is an object like the Earth. So this effort has never been done in such a way, and indeed it is extremely difficult technologically, and it will require the best instruments that we have at disposal at this moment to be able to do that.
And although NASA's Kepler was a wonderful mission, as you point out, the models it came up with were that perhaps 50% of all stars in our Milky Way harbor planets, but the error bars are very large. And why is that?
Yeah, error bars are very large because statistics are small, and because also the stars observed by Kepler are relatively much fainter than those that PLATO will observe. So it was not possible to confirm these objects in general. So in order to do that, you need really to observe a large number of stars which are bright. And this is the concept of PLATO. That's why PLATO will be able to answer this question, or provide at least some meaningful constraints.
You're going to put hard numbers.
Hard numbers.
And so we heard a lot about the TRAPPIST system, which 7 planets. They're all terrestrial, but orbiting a very tiny M dwarf, a red dwarf. And what's your own personal view of that? I mean, none of those are remotely Earth-like, are they?
Well, there are many systems that have tightly packed the planets. They have been found, and those one particularly found about around M dwarfs may be also in the habitable zone of the stars, because the smaller the star, the closer is also the habitable zone. But there are some other difficulties. The stars are more active, they are more complex, so they are completely different system from our own solar system. It's not the same thing as answering the question how many Earth analogs there are in the galaxy. This is a completely different question, also from a technological point of view. And it couldn't be done so far because you need to observe at least for a few years to get at least the signal of these objects. So,
and you're going to be able to observe, 2 years, maybe 3 years, before switching your field of view. You're going to have a pre-selected list of stars to observe within the galaxy.
Yes.
And but the key to PLATO is that you're going to be taking photons from these stars for long enough that you're going to be looking for dips as these planets transit across the face of their star.
Yes.
And you're going to know enough about the stars and clearly see the planets as they transit across the face to be able to say pretty much with some certainty that this is an Earth-like star, correct? Earth-like planet, rather.
Yes, that's the point. We need to pre-select the stars because the field of view is so large that we cannot simply observe and download all the images that we will take of that field. So there is the need to pre-select the targets, and therefore we will put some windows, let's say, around each target in order to download them or to collect the photons from these windows and to analyze the time sequence of the luminosity time sequence of these objects and detect the dips that will tell us that there is a planet like an Earth-like planet, for example.
And hopefully, PLATO will be able to give us a better understanding of the frequency of architectures of planetary systems which may resemble ours, which heretofore we haven't had this data, correct?
That is the big question, and it's our hope that we will be able to reach this result. Not only detect one, for example, which would be already a great result, of course, but reach some conclusions about the frequency and the statistics. Do some statistics with this object. So have a first catalog of Earth analogs in our close universe.
And there's one big caveat that you mentioned in our interview, and I'm glad you did, and it doesn't get enough play in the media, and that is the fact that we benefited from a serendipitously large moon, an anomalously large moon, which stabilized our Earth, which allowed for a stable climate to evolve. Now, of course, there are astrobiologists out there who say, oh, it doesn't matter about the moon. Who cares? Maybe with billions of other stars, you're going to have something similar that happen, or you could be on a planet that's tidally locked with its star, so that only one side faces the planet, and you can still have life. But I mean, what are your thoughts on that, Marco?
Well, if we stick on what we know, the only thing that we know at the moment is about the Earth, right? And there is this thing about the Earth, that it has such a big moon. So is it fundamental or not? I don't really have the answer. But if we want really to say something remaining close as possible to reality, so we should admit that there is this moon. At the moment, we didn't detect any exomoon, for example. Not only we don't know the frequency of Earth-like planets, we don't know the frequency of moons. So basically, we don't know anything to answer this question, and that's why we have to go there and look and put down some numbers and start to answer this question.
So unfortunately, we're still early days on astroseismology and astrobiology. Thanks so much, Marco, for your time here on this beautiful day on the island of Sicily.
Thank you.
We can appreciate our own planet here. Thank you very much.
Thank you to you.